Hey class, hope everybody's doing well. This is the Algebra 1, Unit 6, Part 2, Practice Test Review. I'm going to go over all the problems. I think it's about 14 in total. If you have any questions beyond this, please feel free to email me at any time. I will get back to you as soon as possible. All right, so now we have our first problem, which is number 1, and we have what is the coefficient? Well, this is an easy one. Remember, the coefficient is simply, there we go, it's simply the number in front of the variables. So in this case, it's 9. The coefficient is 9. If we had something like this, there is no number there. Remember, when there's no number, we understand that there's an invisible 1. So in this particular problem, right, let's call this 1b, right? In this particular problem, 1 would be the answer. All right, let's scroll down to number 2. All right, what is the equivalent expression to q to the third power multiplied by q to the 11th power? Here we are going to just simply multiply. Remember, when variables are multiplied by a like or the exact same variable, you're just going to add the exponents. So we have q to the third power times q to the 11th power. That's going to equal q to the 14th power. 3 plus 11 is 14. All right, here we're just going to multiply the like terms, right? So 4 is like to negative 8, and a to the third power, you can multiply with a, and then b to the third power, you can multiply with b to the second power. A couple of things we have to remember. When we see the parentheses with no sign in between, there's no plus, there's no minus, we know there's multiplication. 2, you can only change the numbers when you multiply it by another number. So here, for instance, we have negative 4 times negative 8. Negative 4 times negative 8 is going to give you a positive 32. Over here we have a to the third power, and then I'm going to use a dot because you will see this on the test. Now we just have a, but you have to remember when there's no exponent, we're going to have the exponent of 1. Then we're going to have b to the third power times, and I'll use parentheses again, b to the second power. When there's no sign in between the parentheses, it means multiplication, right? So a to the third times a to the first. We add the exponents when we multiply. So that's going to be a to the fourth. Here we have b to the third times b to the second. We add, so it's going to be b to the fifth. Our answer is just going to be these three terms together. So our answer is going to be 32, a to the fourth, b to the fifth. All right, we'll scroll down, go to the next one. Now we're going to take a power to a power. This here means that the variable cannot equal 0. You guys remember that if there's a 0 on the bottom, that's going to be undefined. So they're saying this cannot be undefined, right? So if you see this, do not worry about it. Just evaluate it like we know how to do. So we're taking powers to another power. Well, when you take a power to a power, you're just going to distribute the power to each power inside, right? So it's going to be x to the second power times 4, y to the fifth power times 4, and then y to the eighth power times 4. What's going to happen here is you're going to see x to the eighth power and y to the 20th power over y to the 32nd power. Now, we have two variables that are the same that are being divided by each other. Because they're the same, we have to simplify here. So we know that y to the 20th and y to the 32nd are the same. So when we have division amongst variables with the same exponent, we are going to subtract. When you divide, you subtract. When you multiply, you add. So now we're subtracting here. The bigger number is on the bottom. Because the bigger number is on the bottom, we're simply going to subtract. So x to the eighth is staying up there. We're just going to do 32 minus 20, which is going to leave us with 12, right? So if we do 32, let's say we go over here, y equals 32 minus 20. Always take the smaller number and put it down. Now your leftover is going to be x to the eighth over y to the 12th. That's your answer. All right, let's go on to the next one. So we have what's the equivalent to b to the 13th power over b to the 4th power. So what we have here is the same thing we had in the previous example, except the higher exponent is on top. Now because the higher exponent is on top, we can rewrite this as b to the 13th power minus 4. And that's going to equal b to the 9th power. Now there's nothing underneath. So technically there would be a 1 there, right? But we don't need to write that 1, so your answer just be to the 9th power. I'm still getting used to writing with this new technology, so just bear with me. All right, so here we have a couple of steps that we need to do. First, we need to distribute, simplify, then we're going to need to simplify by division. So we're going to have to distribute this -2 to each of these. So we're going to rewrite that, and it's going to be x to the 4th power, y. Remember, there's an invisible 1, so you can go ahead and tag that in. And then z to 11th power. That's an 11, not a 4. And then we have x to the -2nd power and y to the -4th power. Now we have negative exponents. We do not deal with negative exponents. We have to make the negative exponents positive before we do anything. To make them positive, we move them up and we move that up. All right, so we're going to come over here. We're going to continue working. So we have x to the 4th power times x to the 2nd power. Now these are all to the top. They were in the denominator, now we push them to the numerator. So now we have y to the 1st power times y to the 4th power, and we still have z to the 11th. So now we have to combine the like terms, right? Or simplify the like terms. So we have x to the 6th power, we have y to the 5th power, and we have z to the 11th power. That would be your final answer. So like I said at the beginning, we had a couple of steps. Got to get rid of this exponent, right? So we multiply. When we multiply, they gave us negative answers. Because they're negative answers, we have to get rid of the negative exponents. So we take the negative exponents, we push them to the top. Once we do that, we see here that we have x to the 4th power times x to the 2nd power, and that becomes x to the 6th power. Once again, that's an invisible 1, so 1 plus 4 is 5, and then we just, z to 11 just stayed the same. All right, here, same thing if z does not equal 0. All right, so now we're looking at this. There's nothing to multiply here. There's no extra exponents that we have to do. Now we see what can we simplify. So we see that we can do 32 and 4. So we'll just make that 32 divided by 4. And 32 divided by 4 is 8. So 8 is just going to stay on the top. Just write that over here. Right, we have the y as well. So we'll do y. But there's really nothing to simplify the y. So the y is just going to come over here in our answer. Then we have z to the 5th divided by z. Right? There's nothing to simplify that y, so it just carries over. So now we have z to the 5th divided by z. Well, what's the exponent of z? We don't see the exponent, we know that it's a 1. So now we have 5 divided by, we're not divided by, we are dividing, but when we divide, we subtract. So 5 subtract 1. So remember, we could write that as z 5 minus 1. That's going to give us z to the 4th power. That would be your answer there. All right, moving on. All right, simplify the expression here. We have to see what we can combine, what's like, and how we can simplify those. So we have 22 divided by 11. That is like, so I'm going to go ahead and break that. That negative, it doesn't matter where you put it, right? So remember this, -3 over 6 is the same thing as -3 over 6, which is the same as 3 over a -6. They all equal -1/2. Or if you put in a calculator, they all equal -0.5. Okay? So it doesn't matter, but for our sakes, I just like to take the negative and put it on top. So I'm just going to do -22 divided by 11. Now, -22 divided by 11, I know that that's -2. The bigger number's on top, so the answer is going to stay on top. So I'm just going to write -2 over here in my answer with a fraction bar. I also know that a to the 4th power, 5th power, excuse me, Get that out of here. Let's go a to the fifth power over a. Now we're dividing here. What I'm doing now is just breaking these up into the three different fractions that I see, right? If I draw a straight line, that's one fraction on that side. That's the second fraction here. That's the third fraction there. I'm just making it nice and easy. There's no exponent there, so that's 1. So I know that it's going to be a fifth power minus the first power, which is going to be a to the fourth. Because it's on top, we're going to leave that on top. So that's going to be a to the fourth power. Now I have b to the third power divided by b to the third power. Well, that's the same number. So anytime, let's say we had 9 divided by 9, that would equal 1. If we had 5 divided by 5, that would equal 1. In exponents, it would be b is equal to 3 minus 3. 3 minus 3 is 0. Anything to the 0 power equals 1. We don't have to write that 1. So we've cleared out the bottom. The 11 is gone, the 8 is gone, the a is gone, and the b to the third is gone. So what we're left with is negative 2a to the fourth power. Let's keep moving. All right, now here we have to simplify the expression. What you should not do is this. Do 4 to the 25th power in your decimals. Simplify it first, right? And now we're going to do 25 minus 9. So we'll have 4, 25 minus 9. And that's going to equal 4 to the 16th power. That can be your answer. Remember, on the test though, sometimes your answer can be in numerical form. So that means if we're working with decimals, I would have to put that in. Let's get this over here. And I would just say 4 and then go, that's my number, 16. It doesn't give us it. Can I change that? Well, because it's a big number, it doesn't want to give us a bigger number. But remember, let's say it was just 4 to the third power, 64. Sometimes if you get that answer here, they're going to only have this answer in the answer bay. All right. So we're moving on to the next problem, number 10. So now, the first thing you have to do is get rid of this number outside of the parentheses. To do that, we're going to distribute the negative 1 to each exponent. So we're going to have 7 to the negative first power. Negative 1 times 6 is going to be a to the negative 6 power. Remember, there's a 1 here, so I did negative 1 times 1, I got negative 1. b, so that's going to be b negative fourth to the negative first. It's going to be a positive 4. Now, we don't deal with negative exponents, so we get rid of negative exponents. How do we get rid of negative exponents? Well, we change them from where they're at. So if they're at the top, we flop them to the bottom. Right, so now where they're at the top of, remember there's an invisible 1 underneath every number. There's an invisible 1 down there. So because there's an invisible 1 down there, these numbers, whenever you have a number with nothing above it, right? So if I have 5, it's automatic 1 underneath there. So that 5 is automatically a numerator, right? It's the same thing as if we have 3 over 4, the 3 is in the numerator. Well, this 5 is over the invisible 1, so now it's automatically in the numerator. So we're going to take this 7 to the negative first power and push it to the denominator. A to the negative 6 power and push it to the denominator. So now it's going to be b to the fourth over 7 a to the 6th, and that would be your answer. I'm going to come down here. The easiest problem of all, anything to 0 power is 1. Anything to 0 power is 1. So if we distribute this 0, all of these would become 1. 11 to the 0 power, x to the 0 power, y to the 0 power. That would equal 1. Or you could just know whenever that zero's out, it's going to equal 1. Alright, because technically it would be 1 times 1 times 1 equal 1. Alright, let's move it on. Alright, so now what is this? We're just going to multiply the like terms here. Right, so let's break it down. Let's do 9 times 8. What does that give us? That gives us a good 72. Then we would do x to the 9th power times x to the negative 6th power. Now here we have a negative exponent. I would try to combine the exponents before I dealt with the negatives. It may make your life easier. So now we're going to add these two together. So we're going to do 9 plus a negative 6, which is just 9 minus 6. And that's going to give us x to the 3rd power. See, now the negative is gone. Then we have y to the 7th times y to the 0 power. Anything to the 0 power is 1. Okay? So because that's true, this is going to be 1 here. So there's two ways you could do this. At 1, right, 2. You could just make this 1 inside of there and say y to the 7th equals y to the 7th, right? Or you could say 7 plus 0 just simply equals y to the 7th. Either way that you think about in your head is fine. And then is there anything to multiply z by? Nope. So the z is just going to stay there, z to the 1st power. So we're going to have 72, x to the 3rd, y to the 7th, and then z. That would be our answer. All right, coming down, last two. We're just going to do the same thing. We're going to go ahead first before we multiply. There is an exponent there. So we're going to distribute there. Bang, bang. So it's going to be 2 to the 2nd power, x to the negative 22nd power. And then we're still going to have 12 x to the next. Isabel, stop yelling. Okay, so finishing here, we're just going to 2 to the 2nd power is 4. We have to evaluate that. Okay, now we're going to make 4, and we're going to do 4 times 12. Then we're going to do x's negative 22nd power, and then that's going to be multiplied by x to the negative 4th power. Here 4 times 12 is 48, and we're gonna add here, so that's gonna be x to the negative 26th power. Remember, put negative 22 plus negative 4 into the decimal, so when you would get x to the negative 26th power. Now we're not done here. We are simplified down to two terms. What has to happen is we have to get rid of this negative 26. So it's going to be 48 over x to the 26. Last one. First thing we're going to do is distribute this 7, 1, 2, 3 times. So we're going to have x to the 35th power, y to the 7th, and x to the 28th. Now, we're going to break this up so that we have the like terms next to each other. We'll do x to the 35th over x to the 28th, and we'll still have y to the 7th by itself. 35 minus 28 is going to be 7, right? So that's going to be x to the 7th power, y to the 7th power. Remember, that's an invisible 1 there, so I did 7 times 1, and I got 7. Alright, you guys, I hope this video helped you out. Again, Unit 6 Part 1 and Unit 6 Part 2 are open for you to take them right now. Go ahead and do your best. Let me know when you've taken it. I'll put in the better grade. Do your best. Watch the videos. Email me if you have any questions. I want you guys to do the best you can do. Let's go ahead and make the third quarter a very good grade. All right, guys. See you next time.